All right, guys, we have a lot to cover today. We're gonna start by, we'll start Notes 2.6 by looking at domain and range, and even before that, talking about what a function is. A function is like a machine, right? It's like a machine right here. And it's kind of not clear, but right here it says input, over here it says output, and you can see the X is going in here, okay? So here's the fact. The inputs are your X values, which are also your domain values, okay? All these three terms mean the same thing. The domain, the inputs, the X values, it's all the same thing. You take those values and you put them in to the machine, into the function, okay? Now inside the function, math happens, and then you get an output, okay? So the output that comes out of the function are your range values, which are your output, which are your Y values, okay? So again, inputs go into the machine, outputs come out of the machine. So let's do a little exercise, mental exercise here. Let's say I took the number 5 and I plugged it into the machine and it came out as 11. Okay, and then let's say I took the number 7 and took the number 7 and plugged it in here, and the math happened and it comes out as, could you predict it? It's actually going to be 15. I hope you guys already see what's going on in this machine right here, in the function machine. One more just for kicks. So let's say I plugged in the number 10. If I take the number 10, put it right into this machine, it's going to come out as, I hope everybody knows, it's 21. Okay? Now, what is happening inside this machine? Well, the 5 gets doubled and then you add 1 to it. That's 11. The 7 gets doubled and then you add 1 to it. The 10 gets doubled and then you add 1 to it. So the function that actually describes that relationship between the inputs and the outputs, or between the domain and the range, or the X values and the Y values, is this function right here. You could write it as f of x equals doubling the X and then adding 1 to it. Or you don't have to put f of x, you could use y. Okay, y equals 2x plus 1. That's the function that, given these inputs, produces these outputs. Okay, so that was a nice little exercise. Again, the f of x, that's just the name of the machine. It says f of x right here. Could be g of x, could be h of x. It's just the name. And you could also write it as y. That's why it says right here on y values. It could be also f of x values. F of x is the same as y. Okay. Anyways, let's move on. In a function, for each input, there's exactly one output. Okay, so you plugged in a 5, you got out an 11. You didn't get out, like, for each input, there's exactly one output. If you plug in a 5 and you get out an 11, if you plug in a 5 again, you're supposed to get out an 11 again. If you get out something different, then it's no longer a function. It's a broken machine. It'd be something else. Okay, so anyway, let's move on and see if we understand the vocab. Check out this question. Find the corresponding range values for the given domain values of d 2, -5, 0 for the function g of x. Okay, so once again, what do they want? They want you to find the range values. Now, what are range values? Range values are your outputs. They're your y values. Okay, for the given domain values. So what does domain mean? The domain, says up here, are your inputs. They're your X values. So they're giving you some domain values. They're giving you some inputs. You're going to take these numbers and you're going to put them into what? Into the machine. But what is a machine? Here's the machine right here. It's called g of x. This machine's called g of x. So you're going to take the d, the domain of 2, and plug it in. The X value of 2 and plug it in. The input of 2 and input it. Okay, you're going to put it in. So they want the corresponding range values, so you're going to say R. You're going to do that funky little bracket thing. And for the 2, let's do this together right here. 3 times 2 is 6, and that's it. Plus 4 is 10. Shouldn't have said that's it, but 6 plus 4 is 10. So when you plug in a 2, you get out a 10. So notice the 2 is first, the 10 is first. That's what's corresponding. So the 10 corresponds to the 2. All right, so then it has a -5. Okay, the -5, let me put this in green. If If I plug in negative 5 right in here, 3 times negative 5 is negative 15, and negative 15 plus 4, that's negative 11. So in green, I'm going to put negative 11. And last but not least, let's take the 0 and plug it in. Plugging in 0 right there. 3 times 0 is 0, plus 4 will give you an output of 4. Okay. Now, believe it or not, the 2 corresponds to the 10 corresponds to the 2, so this is like your x value and your y value. That's an actual coordinate of this graph if you were to graph it, of this equation if you were to graph it. So 2, 10 is a coordinate, negative 5, negative 11 is a coordinate, 0, 4 is a coordinate. But anyway, this is the answer. We found the corresponding range values for the given domain values. We found the corresponding outputs for the given inputs. We found the corresponding y values for the given x values. So we need to get comfortable with the vocabulary first. One other thing, I just want to remind you of function notation. Okay, so when I write this down, g of 2, that does not mean g times 2. When you see this notation, it's actually saying that you're going to take the number 2 and plug it into the g of x function. So if you ever see g of 2, they actually want you to work it out. 3 times 2 plus 4. We already did that. We got 10. But I just wanted to remind you of function notation. All right. So g of 2 means that you're going to plug in 2 into the g of x function. G of 5 would be that you're plugging in 5 into the g of x function. G of negative 7 would be that you're plugging in negative 7 into the g of x function. Okay. So that's just the notation. Okay. We need to become comfortable with that as well. All right. Let's move on to something more interesting. Parabolas. Right now we've graphed parabolas in Algebra 1. We have not done any refresher on that. You might not remember vertex form. Vertex form is a parentheses x minus h close parentheses squared plus k, where the vertex, which is your highest or lowest point, depending on whether it opens up or down, is the location hk, and you must think opposite on h. So I'm pretty sure that a lot of us forgot about this, but let's say that you do remember it. Let's just pretend that you don't remember it. Okay, so we're going to go, instead of vertex form, let's graph this function using inputs and outputs, right? Kind of like it being a machine. So let's go to this XY table, and let's put the number 0 right here in the middle, and then let's put 1 right there, and then 2. And let's also do some negatives. Let's go negative 1 and negative 2. Okay, so these are all x values, these are all inputs, these are all domains, right? We want to find the corresponding outputs, right? So if we go and actually plug in 0 into x, 0 squared is 0, and 0 plus 1 is 1. So for my input 0, my output's 1. I'm going to put a 1 right there. Let's plug in 1 right here. 1 squared is 1, and 1 plus 1 is 2. Let's go to 2. 2 squared is 4, and 4 plus 1 is 5. So you see how we're treating this like a function machine? You're just taking your input, you're putting it in. You're taking your x value and putting it in for x. You're doing the math, and then you're getting your y value out, your output. Remember, f of x is the same thing as y. So when you say 2 squared plus 1, that's going to be 4 plus 1 is 5. It says f of x equals 5, but that really means that y equals 5 when you plug in 2 for x. Now, if you go for the negatives, I haven't been showing my work, but I will show my work when I plug in a negative. It's going to be x squared plus 1. Notice that I put parentheses. That way when I take this negative 1 and put it right in here, it will be a negative 1 times a negative 1, which is a positive 1, and then 1 plus 1 takes you back to 2. Okay, so when I plug in negative 2 right in here, doing it with parentheses, negative 2 squared plus 1, that becomes positive 4, and 4 plus 1 is 5 as well. So let's graph this. Let's go to the coordinate 0, 1. Let's go with 0, 1 first. And 0, 1 is right here. Then let's go to the next coordinate 1, 2. 1 on the x, 2 on the y, it's right there. Let's go to the next coordinate 2, 5. 2 on the x, 5 on the y, it's right here. And let's go to the next coordinate in the negative direction. Let's go with negative 1, 2. Negative 1, 2 is right here. And then negative 2, 5 is up here. Now, I hope you remember from Algebra 1 parabolas that they are symmetrical. Okay, so as you can see, It's like a mirror image from here to here, there to there, but that's not really what's important right now. We just wanted to graph it using inputs and outputs, and we have graphed it. Okay? So the goal for this video, for this section, is to really understand domain and range. Okay, so we graphed it. Now, why do we put arrows on here? Because we know it continues forever, right? It continues to go up forever, and it does continue to go out this way forever, right? Now, you could look at it visually. It'll never go straight up. It continues to go out this way. Or you could even think about it numerically. X's are your inputs. So could you plug in 3? Well, yeah, you could plug in 3. 3 squared is 9. 9 plus 1 is 10. Could you plug in 4? Yeah, 4 squared is 16. 16 plus 1 is 17. Could you plug in 5? Yeah, 5 squared is 25. 25 plus 1 is 26. So my point is that I could continue to plug in any number I want for x, right? So will this parabola exist at 7? Yeah, because at 7, it's going to be way up there somewhere, right? I mean, you know specifically it'd be at 50, right? At 7, it'd be at 50, way off the graph. Why 50? Because 7 squared is 49. 49 plus 1 is 50. Inputs and outputs, right? So will it exist at -7? Yes. Will it exist at 10, at 100? Yes. But it's going to be way off the graph that we have here. So let's now talk about what's important, domain and range, all right? So the domain, we know that the domain are our x values, right? And the range are our y values. So when I ask you for the domain of this parabola, I'm asking you where on the x number line does this parabola exist? Does the parabola exist at 0? Yeah, it's right there. Does it exist at 1? Yes. At 2? Yes. At 3? Yes, even though it's off the graph. At 7? Yes. It exists forever this way, and it also exists forever that way. So the domain, because the domain are the x values, it's kind of like looking at the x number line and saying where it exists on the x number line. So we clearly see that the parabola, it doesn't stop right here and here. So it's not between -2 and +2. It continues to go out in both directions. You could see it numerically, or you could see it, you could imagine it visually, because it continues to go out forever. Okay? So for the domain, it really is going to be all real numbers. Okay, so down here where it says domain of that function, everybody do this. Let's put D and then put X equals all real numbers. Now you could write that symbol for all real numbers, or you could actually write out the words all real numbers. Okay? But that's for the domain, which are your X values. And it's important that you write X equals all real numbers. If you don't put X equals, I don't know if you're talking about X values or Y values. Okay? So now let's talk about range. So if the domain was looking at the graph and seeing where it would land on the x-axis, on the x number line, the range is looking at where the graph is on the y number line. Okay, so where's the y number line? The y number line is right here. Yes? So does this parabola exist at 1 on the y number line? Yes. Does it exist at 2 on the y number line? Yes. At 3? At 4? At 5? At 6? At 10? At 100? Yes, because it's going up forever, right? So does it exist at 0? No. Or at -1? No. It doesn't exist anywhere down here. It's all at the value of 1 or above. Does that make sense? So the range is going to be, remember, range are y values. You're going to say y. And how do we say at 1 or above? We say greater than or equal to 1. So that's the range of this parabola. Now that might be kind of tricky, but we're going to do several more examples with domain and range because it could be very confusing, domain and range. Just remember this, the domain is looking at your x values, the range is looking at your y values. The domain is looking at it from left to right where it exists, and we know it exists in that way forever and this way forever, but the range is looking at it up and down, and it only exists from this value up. Okay, so let's look at some more examples, and we're going to get into some funky situations here. First of all, this might be a little blurry on your worksheet. This is the coordinate -2, 4. That's that dot right there. This is the coordinate 5, 1. That's that dot right there. And all we're looking at is the line segment from here to here. Now, it doesn't even have arrows, so it doesn't continue forever. It actually has an endpoint here and an endpoint there. Hopefully you guys remember endpoints from geometry. And then the rise and the run, they're just showing you what the slope is and what the run is, right? So the rise is technically -3, and the run is 1, 2, 3, 4, 5, 6, 7. So the slope on this line, even though they're not asking for it, it's -3/7. If you were to use the slope formula, with the coordinate negative 2, 4 as x1, y1, and 5, 1 as x2, y2, you'd be able to get that slope negative 3, 7. But that's not what's important here. What's important here is that we recognize how to state the domain and the range. The domain is looking at your x-axis, looking at your x number line. So let me ask you this. Does this red segment that goes from here to here, does it exist at the x value of negative 4? No. Does it exist at the x value of negative 3? No. Where does it exist? Right here at negative 2. And does it exist at negative 1? Yes. At 0? Yes. Even at 1/2 if you wanted to? Yes. At 1, at 2, at 3, at 4, at 5, but it doesn't exist at 6. So where's the domain? Where does it exist in terms of the x number line? Well, it's between here and here. And what's this value and what's that value? That's negative 2 and 5. So we need to state this domain as a compound inequality because, again, your domain are your x values, so you're going to put x in the middle, the smaller number negative 2 on this side, the bigger number positive 5 on this side with the less than or equal to symbols. Why or equal to? Because these are solid dots. Solid dot here, solid dot there. Does that make sense? So that's your domain of that segment. And we're not going to be, well, actually we might have to do this on piecewise functions later on today. Now the range. The range is the same concept, but instead of looking at your x number line, we're going to be looking at our y number line. Okay? So let me do this in yellow. Does a red segment exist at positive 5? No. Does it exist at positive 4? Yes. At 3? Yes. At 2? Yes. At 1? Yes. At 0? No. So the range, it exists between this y value of 4 and it also exists between this y value of 1. Okay, so range is going to be y in the middle, the smaller number on the left side. What's a smaller number in terms of the y number line? 1. What's a bigger number in terms of the y number line? 4. And we're going to put the less than or equal to's right there. So we have stated correctly the domain and the range. Okay, the more we do, the more comfortable you're going to get. And I purposely threw out some weird stuff on these graphs, like segments instead of lines. Like a circle, right? This is not geometry, we're having a circle here, but what would the domain of this circle be in terms of x's? Because domain are your x values, range are your y values. So in terms of x's, where does this circle exist on the x number line? Between the 0 and the 6, perfectly. So what is the domain? We're going to say the domain, put the x in the middle, and then what? Smaller number on the left side. What's the number on the left side? 0. Bigger number on the right side. What's the bigger number? 6. Okay, now what symbols belong there? The less than or equal to, the less than or equal to. So that's our domain. How about the range? The range is going to be the y values. And what's the max height of this circle on the y number line? And what's the minimum height of this circle on the y number line? Negative 3. So smaller number on the left, the negative 3, bigger number on the right, less than or equal to symbols. Starting to make sense? Getting a little more comfortable with it? I hope so. Now, this is something that we practiced yesterday. Hopefully we remember. And if you don't, pay attention right now. When we graph a line that says x equals 2, that's going to be a vertical line up and down through the x-axis at 2. Okay, so again, the only thing that this cares about is that your x values are 2. It's simple as this. Go to your x-axis. It says x right here. Here's your x-axis. Go to the value of 2. Put a dot right there, and then draw a vertical line right through it. Vertical line right through it. We graphed it. Put some arrows on it. That means it goes up and down forever. Okay? And how about the y? Well, the y equals a number. Then you go to the y-axis. Here's the y. Go to the value of negative 2. Put a dot right there. And then that's going to be a line right through it, which in this case is horizontal. Once again, a reminder. X equals a number is a vertical line through the x-axis at that value. Y equals a number is a horizontal line through the y-axis at that value. Are we cool? All right, that's graphing. But now let's take a look at those graphs and let's state the domain and the range. Let's look at the red line. What's the domain of the red line? What are your x values of this red line? 2, and that's it. All right, so for domain, you're going to put the d, and then you're going to put 2, x equals 2. X equals 2. Because this red line does not exist at 1, it doesn't exist at 0, it doesn't exist at 3 or 4, it only exists right here at the value of 2. So sometimes it's an area, sometimes it's just one specific value. How about the range? The range are your y values. Let me put a y right here. Now the question is, does this line exist at 1, yes. At 3, yes. At 10, yes. At negative 10? All real numbers. Perfect. So y is all real numbers. Okay? Man, this is a ridiculously long video, but I hope we really understand domain and range. How about the blue horizontal line? What's the domain on that guy? Okay, now it's very important that we put x equals all real numbers. You have to state that it's x. Remember, domain is x, range is y. How about the range? What's the range? Y equals negative 2, right? Dang. Weirdness, huh? This is a piecewise function, which we're going to be graphing and stating soon. But right now, I just want you to look at this weird graph, and I want you to state the domain and the range. So, what is the domain? On the x number line, where is it at? Does it exist at negative 5? No. Right? Well, this is 4. Does it exist at negative 3? No. Where does it exist? Negative 2. And it goes, there's negative 1, it's there. 0, it's there. 1, it's there, but it's not at 2. So this is a compound inequality. Let's state the domain. You put x in the middle. Smaller number on the left side. What's a smaller value on the left? Negative 2. What's a bigger value on the right? Positive 1, right? So negative 2, positive 1, and you put the less than or equal to, the less than or equal to. Now let's go in terms of y, okay? Now first of all, this open dot, it's kind of funky because it's not quite at the value of 1, 2, 3, 4, 5. Let's say it's 4.5, okay? So the y value has to be below 4.5, but it has to be above negative 1, 2, 3, 4. Does that make sense? So the minimum value, when in terms of y, this is going to be kind of confusing. The minimum value is this one down here, which is negative 1, 2, 3, 4. So we put that negative 4 right here, and the bigger value is up here, and that's roughly 4.5. So we're going to put positive 4.5 on this side with the appropriate inequalities of less than or equal to. Oh wait, I'm sorry. I did something wrong. What's my mistake right there? This inequality on top is an open dot, right? So I should not put a solid line underneath it. So I need to erase this one at 4.5. That's just less than 4.5. So that's a super long video on domain and range. I hope we have a better understanding of it. I'll make a separate video starting piecewise functions.